Hello, this is Brother Cromer from the Math Department. This is a continuation of the lessons dealing with inference for one proportion. And so I talked about in the last video an example which dealt with proposition 8, and we created a confidence interval. So let's go through a second example here. Okay? So a sample of cases from the Superior Courts in Massachusetts was used to investigate the outcome of first-degree murder trials. The sample included 57 subjects who were on trial for first-degree murder. Out of these, 9 defendants were found not guilty. Construct and interpret a 95% confidence interval. So first of all, what we want to do is we want to get the estimated sample proportion, or in this, what we want to get is p tilde of those in favor. So what we're going to do is we're going to take x plus 2 divided by n plus 4. So x is the 9 who were found not guilty. So 9 that meet a certain characteristic, the characteristic being those found not guilty. The 9 plus 2, and then that becomes 11, and then n is our sample size, which is 57, plus 4, which we have that to get 61. So 11 divided by 61 is 0.0180. Okay. Step 2 is check the requirement. So the requirement is that the sample size is greater than 5, and since our sample size is 57, the requirement is met. Okay. The third issue is now construct and interpret a 95% confidence interval for the true proportion of those who are found not guilty. So what we'll do is we'll take, here's the formula for it, we're going to take our point estimate, which is p tilde, which is 0.180, and we're going to add and subtract a margin of error. So we're going to take the z critical value for the 95% confidence interval and times it by everything within the square root and then square root it, where we take 0.180, which is p tilde, times 1 minus p tilde, divided by 57 plus 4, which is 61. And when we solve for that, we get the lower bound being 0.084 and the upper bound being 0.277. So how do we interpret this? Well, we say that we are 95% confident that the true proportion of subjects that are found not guilty of first-degree murder is between 0.084 and 0.277. Okay? Now, what I want to do here for just a moment here is that I want to go to a spreadsheet here, and that this is available to you in iLearn, and if you have questions of where to get it, you can talk to your instructor, your TA. But we can use this tool in Excel to be able to calculate that confidence interval for us. All we need to do is input what x is and what n is. So if we put in 9 for x and 57 for n, we can get a confidence interval here. Parenthetically, we can also up here check our requirements. Now our sample size is 57, but this list here that our requirement is the value of our sample size is greater than or equal to 5, so the requirement is met. We can also use this tool as well when we're dealing with a hypothesis test. Okay? So now a couple of other things here with confidence intervals. So sample size calculation. So the sample size required to estimate the population proportion with a level of confidence, 1 minus alpha times 100%, with a specified margin of error m, is given by, and this is the formula for it, n, which is our sample size, is equal to z star divided by m, and that's squared. Z star is our critical value, m is our specified margin of error, times p star, which is this is another definition that you need to know concerning p star times 1 minus p star. And this is if we have what's called a prior estimate of p. That's what p star is, a prior estimate of p. If we don't have a prior estimate of p, this would be the formula. This is more of a conservative formula for getting the sample size. It's basically z star divided by 2m, and then we square that. Okay. For example, if we have a desired margin of error of 0.03 or 3% with a 95% confidence for the proposition 8 problem, where the prior estimate of p is 0.60, okay, what we would do is we would take our critical value, which is 1.96, divided by our desired or our specified margin of error, which is 0.03. We square this, times it by our prior estimate of p, which is 0.6, times 1 minus the prior estimate of p, and then we get a number of 1024.43. Regardless of what number we get, if it's 1024.2 or 1024.8, we always round up, and so we round up to get a number of 1025. The other example, the desired margin of error is 0.03 or 3% with a 95% confidence interval for the proposition 8 problem, where there is no prior estimate of p. Then we use a second formula where we take 1.96 divided by 2 times the desired specified margin of error, which is 0.03. We square that and we get a number of 1,067.11. We round that up to where we get a sample size of 1,068. Okay. So now so one more example, and then perhaps you will want to try this on your own here to see if you can figure this out. The desired margin of error, 3% or 0.03, that's desired margin of error with a 95% confidence interval sample cases from the Superior Courts in Massachusetts, where the prior estimate of P is 0.82. So what we would do is that we would take 1.96, which is our critical value for a 95% confidence interval, divided by our desired margin of error of 0.03, times our prior estimate of 0.82 times 1 minus that prior estimate. We get a sample size number of 630.02, and we round up to 631. Okay. Now, a couple more thoughts on confidence intervals. A level of confidence for describing the process is described as a process of creating an interval that predicts the proportion P, which is unknown. So approximately 1 minus alpha times 100% of all possible confidence intervals contain P. So if alpha is equal to 0.05, we have a 95% confidence interval. So approximately 95% of all of those 95% confidence intervals will contain P. This does not mean the probability of containing P, or the chance, another word to describe probability is chance of containing P. The interval either captured it or do not. So the probability of capturing the true population proportion of P is either 0 or 1. Okay? So now, the requirements to check for doing the one proportion confidence interval. First of all, the sample is obtained from a simple random sample, and the requirement for doing the confidence interval is n is greater than or equal to 5. So we can assume that the distribution of P hat is normal. And so that's the reason, sample size being 5 is small. That's why we use the +4 estimator when doing a confidence interval, because we have a smaller requirement. Now the descriptive statistics you use, the numerical descriptive statistic is just the sample proportion, which is P hat, and then we can use a pie chart or a bar graph. And here's an example of a pie chart or a bar graph, if I can find it here. It's under, I'll go to my SPSS output. Here's an example of a pie chart, and here's an example of a bar chart for the Proposition 8 data. Now P hat would just be 54%. You can get P hat from the graphs. Okay, these are example of SPSS graphs. You can get similar pie charts or bar graphs in Excel. Okay. So now what I'm going to do is I'm going to stop the recording. I'm going to continue with part 3, dealing with hypothesis tests for one proportion.